Let's continue with the age detection model. I mentioned a few minutes earlier that we created a TensorFlow model, and fortunately these models are mostly like containers, so you can just extract information from these models and create other format of models. So you can fortunately convert TensorFlow into something called Onyx. What Onyx is, it is a quite common format of neural networks. So it is supported by many big companies, and it seems that it is the common denominator of neural network usage. You can read a lot on this page, but what important is that you can see that lots of companies support this Onyx models. I think this is a very state-of-the-art technology of neural network processing. And what interesting is, this Onyx project has an Onyx model zoo, and you can just download any kind of pre-trained model from their homepage related to vision or language processing or other interesting topics. What I did in this age detection project, I just downloaded one TensorFlow model and I converted it to this Onyx format. That is quite simple, so it is just invoking a command. So in this project, I will show you how we can use a pre-trained model in our code. We don't need to train our models if it is not necessary. So in this case, what we will need is the Microsoft ML library, latest one, 3.0, the image analytics, the Onyx runtime. This is the runtime that can run this format of neural networks, and we need transformers so that we can use the Onyx runtime in our pipeline, and we use this Sharp library, which provides the mathematical background to Onyx runtime. Of course, you can use any GPU supported library, but I just use the generic ones here, so everything will run on my CPU, not on the GPU. But yeah, the code can be made a little bit faster if it runs on the GPU and not on CPU. So in our case, the pipeline will be very simple. So we just create the ML context and we just load the data. In this case, this is an empty enumerable. Why we do this? We load nothing and we resize this image and then extract the pictures out of it, and then we just call the Onyx runtime. So why we use an empty collection is, if we want to create a model, we need to fit the pipeline. But to be honest, this model has been fit, so we don't need to refit it. That's why we provide nothing, but we create a pipeline, a properly configured pipeline, feed it with 0 data, and our model will be good to create a prediction engine. And when we do the prediction with real existing data, Interestingly, in the images folder, you will see only one JPEG file. So if we use the predict method in our engine and we provide the real image path to the pipeline, then it will result the result. We will check what the result will be later. So if we provide the image path and we call the predict, then the pipeline will be utilized. It will load the image from the images folder. In this case, the images folder is specified, so we don't use any random data, just one. The output column name, this is the virtual, not yet existing column, will be image. This will be the input for the next step. Here is the next step. We just resize the image to the correct image size. Why do we do this? If we go back to this Netron and we come to the edge detection, and we can of course load the Onyx models into this Netron application, of course, and you can see, maybe I can resize it a little bit later. So the input of this model should be an image with RGB values in each pixels, and the dimensions should be 224 times 224. So it takes one picture with RGB and with specified row and column numbers. Maybe not in this order, but fortunately it is a square image, so it doesn't really matter. And then it will do a lot of things, and other lot of things, and other lot of things, but in the end it will provide two values, this loss3 / loss3 underscore y, and it will be a vector. The first dimension is 1 and the second dimension is 8, and each element of this output vector or tensor is a little bit more generic than vector, because an integer is a tensor, a vector is a tensor, a matrix is a tensor, an n-dimensional matrix is a tensor, so tensor is a little bit more it is a broader term than the vector. So it will result an 8-element vector, and each element of this vector defines the probability of this age range. So if we check the age detection output, we can see that we need to specify the column name exactly as it was defined on this page. So this one here should be exactly what here is defined, and we will receive an 8-element vector, and later on, if we do the prediction, then we will just create the output string based on these values. Let's run the code. Maybe it will be easier to understand. Very good, very nice. We just defined the pipeline. Fitting the model is very, very simple because we just don't provide anything. We create the prediction engine and we does the predictions. So what we received in this result is, as I mentioned, only probabilities, but we can see that there is something interesting. The 5th element, or actually the 6th element, is almost 1. So this model is quite sure about my age or the age of the person who is in the picture. Okay, very nice. It is a little bit boring, but so the prediction engine, the deep learning engine in this case, or the neural network, is quite sure that my age is between 38 and 43 years. And to be honest, it is almost true. So the next step is 48 to 53. So yeah, this range is quite accurate. I'm quite happy with this solution. So yeah, consuming any pre-trained model is not trivial, but not super complicated. So if you have good eyes and you can match the input and the output of the pre-trained model, then you can create very nice and very interesting applications.